Hello, my name is Brad Baker, and I'm a developer for the BrainForge project. BrainForge is a web-based application for the pre-processing and analysis of neuroimaging data. Today, I'm going to walk you through some of the tools that we currently offer on the site, such as analysis pipelines, data management tools, and pre-processing. Let's go ahead and take a look at some of those options. We offer 4 broad categories of analysis tools on the site currently. First, we offer the statistical modeling of data in the form of standard regression models. Next, we offer classification of data via a suite of multiple classifiers such as multilayer perceptrons, support vector machines, logistic regression, and more. Next, we offer online support of the GIFT toolbox, which offers the performance of the Group Independent Component Analysis, or Group ICA pipelines, and Dynamic Functional Network Connectivity, or dFNC pipelines. Finally, we offer the support of multiple neuroimaging pre-processing tools for various modalities, such as structural MRI, functional MRI, and diffusion MRI. Today, I'm going to walk you through 4 different analyses, how they are created from parameters to data upload to results. I'm going to show you Group ICA, dFNC, and structural and functional MRI. So let's go ahead and take a look at the standard process. So suppose I want to create a Group ICA analysis. What I will do first is create a set of parameters that will be used for this analysis. I'll go ahead and select Group ICA and add a new set of parameters. So here I'll call this set of parameters amazing parameters. Let's call this for Group ICA. And describe them as saying these params are amazing. And I'll call this, what version should we do? Let's just do version 0.0001. Now I can actually set the parameters that will be used for my Group ICA analysis. I could do a standard Group ICA, ICASO, or MST. Let's stick with the standard analysis for now. Let's stick with spatial rather than temporal ICA. And for our algorithm, rather than the standard Infomax ICA, let's actually select Gig ICA so that I can use a reference template. I'll keep all of the other settings the same for now. For my template, I'm going to choose the NeuroMark template, which is created from multiple neuroimaging studies and is generally a good reference template for Gig ICA. Let's go ahead and create this parameter set, and now you can see it here. So I had good parameters earlier, but now I have amazing parameters. I can go ahead and view these just to make sure everything is right. Yes, parameters are amazing, great, everything looks good. And I could edit them if I wanted to, but I don't because these parameters are amazing. So let's go ahead and actually run the analysis now. So click through and look at Group ICA. And I could upload more data to analyze, but I actually already uploaded some data, so I'll just go ahead and use that for now, and I'll talk about actual image or data upload later. So here I have the fBurn study, which I've uploaded. I could select the entire study if I wanted to run all 300 or so subjects from that study, but let's go ahead and just select 2. And let's go ahead and call this analysis an amazing Group ICA. And we'll describe it by saying this Group ICA is gonna be amazing. And I'll go ahead and click through and select the parameters that I created before, my amazing parameters for Group ICA. Now, if I wanted to run my analysis, I would just go ahead and click the Run Analysis button. But because I had some foresight, I actually went ahead and already ran Group ICA, so I don't have to sit and wait here during this video. And I will show you those results in a moment. But before we look at the results from that previous analysis, let's go ahead and take a look at the analysis results dashboard, which shows me a list of all the analyses that I ran previously. So here I have this Group ICA that I ran before, which I called Gig ICA Demo. I can actually, for this analysis, go ahead and look at the parameters that I actually ran with. So you can see I named it just Gig ICA. I ran with Gig ICA and did everything else standard using the NeuroMark template, of course, as my reference. I could also download the results if I wanted to, but for now I'll just keep everything in the browser. And I can also look at some provenance information, such as information about the CPU that was used on the machine this ran on, amount of available RAM, more details about RAM, the OS, our Python distribution that was used, and information about any Docker images that were used during the analysis. So let's go ahead now and take a look at the results for this Group ICA that I ran earlier. So here you have the summary report for our Group ICA analysis. We have a table of contents where we could jump to individual points in the actual report, but let's go ahead and just look through. Here we have some summary information. And of course we have our beautiful looking spatial map visualizations here. Here we have some activation that looks quite nice. We have some time courses here, our dynamic range information. We have this for all of the components that we generated from our analysis earlier. Let's go ahead and scroll through a little bit more quickly and just look through. So here we have some plots on kurtosis stats for my time courses and my spatial maps. And here I have the actual static fNC matrices here, which have a nice, quite nice module structure. Speaking of fNC, now that we've run Group ICA, we can actually click back and run a dynamic functional network connectivity analysis, rather than go through the entire set of steps of creating parameters again. I'll just go ahead and show you the parameters that I used for this dFNC analysis, since I can do this with the dashboard. So here for dynamic functional network connectivity, I select a previously run Group ICA that I want to use for that analysis. I can set the number of clustering iterations, the distance metric used, the window size, temporal resolution, and other details. Now for this analysis, let's go ahead and take a look at what some of the results look like for dFNC. So here I have the standard deviations. Let's skip through these and look at our actual states. So here we have a quite nice module structure. Looking good, looking good. For the second state, here we have our third state with a very good block structure again. And yeah, our fourth state up here, and our fifth. We have some summary information about the number of cluster occurrences during each of the time points in our data set. We have information about state transitions as well as subject-specific information. And of course, we have the metastate analysis. All right, it's looking quite good. So that's it for Group ICA and dFNC. Let's go ahead and take a look at some of our pre-processing tools. So like I said, we have structural and functional MRI pre-processing. They'll end up functioning in very similar ways. Let's go ahead and look at the parameters that I could select for the structural MRI pre-processing that I ran previously. So I ran VBM for structural MRI, and I have some parameters that I configured here. So here I had a quite high smoothing kernel. I did not reorient my image at all, and I did not change any of so these are the standard segmentation parameters that you would get with SPM. And we can go ahead and dive in, take a look at what those results would look like for my segmentation. So here I just ran with one subject. Here you can see the gray matter segmentation map, the warp and modulated image, and the smoothed image, which you see has that very thick kernel. I can also look at my soft tissue segments, my white matter segmentation map, the air segmentation maps, and the cerebrospinal fluid. I could then download the results if I wanted access to the actual Nifty files. And here you can see I have some information. This subject was actually flagged for quality assurance based on correlation with the reference. Let's look now at functional MRI preprocessing, which again is relatively similar to the structural MRI counterpart. Excuse me. So here we have the parameters for functional MRI. Again, a smoothing kernel, which I left quite high. The reorientation parameters, realignment parameters, my normalization parameters. Again, I left everything as default for now. And we can go ahead and look at what that analysis looks like. So here again, we have a QA summary. This subject was not flagged for quality assurance. Thank you. That's very good. We can go ahead and look at the mean image, the slice time corrected image, the normalized image, which you see has omitted the eyes, and finally the smooth image with that very thick kernel. So that's basically it for functional MRI. Again, I could download the results if I wanted to. So that's it for what I'm going to show you for analysis pipelines for now. Stay tuned. Look out in the future for more details on other analyses. Let's go ahead and take a quick look at some of the data management tools we currently offer on the site. So we currently offer managed studies and uploading and creation of studies via the actual GUI on the site. So here I have a demo study that I created with just placeholder information, demo study, demo site, and I haven't shared it with anyone yet. I have 2 versions of fBurn, which I created for testing reasons, again, with the various metadata information. I could add a new study if I wanted to. Let's call this the Amazing Study. Let's abbreviate it as Amaze. So I'll add it to a site. So here I have the Trends Center as a site already, and I don't currently have any PIs as users here because this is just a demo, so I can't add any PIs, but I'll go ahead and if I had any PIs enrolled, I could go ahead and add them in there. I can also create and look at site information here on the website, and I can add information about sites. So let's call this site Amazing Site. And you can see it's gone ahead and added this for me here. And I can look about various member information, invite people to it if I wanted. Of course, this is just a demo, so I'm not actually interacting with anyone on here currently. And now we have the actual managed studies table. So here on this table, all of the data in each of the studies that I uploaded previously has been arranged into a table where I can navigate through, click through the table, and look at each of the subjects and sessions and series for that table. Let's go ahead and click to the end. So you can see I actually uploaded a site with a subject with a few MP-RAGE images. And I've gone ahead and assigned some analysis steps to this MP-RAGE image. So I've added 2 steps of VBM with 2 different sets of parameters. So here I had this other MP-RAGE modality, the RMS. Let's go ahead and assign this a modality. So here you can see the modality assignment page for different protocols. I've already assigned the structural MRI protocol to our MP-RAGE 5e images and diffusion MRI to our DTI images. Let's go ahead and assign another modality to the T1 structural images. Let's assign this, of course, structural MRI. And now you can see if I go through, I can either go back to the managed studies table and navigate to the corresponding subject's T1 structural image, but it's a little bit exhausting to do that. So let's just go to this analysis matching page. I'll go ahead and I'll select, so I know V. Calhoun is my placeholder for the demo study. And I can go ahead and I can see these corresponding protocols for the study that I created earlier. So here I have the MP-RAGE with these 2 steps that I showed you before. I have a DTI modality that I could assign steps to, and I have this T1 structural protocol, which I assigned the structural MRI modality, and I can go ahead and add different analysis steps to here as well. So let's do voxel-based morphometry again, and let's just use whichever parameters I want, and I could add more steps as new analyses come out. So for example, I could run with a different study. So if I wanted to select fBurn, I'll go ahead and assign this data the functional MRI modality. I'll go back to this analysis matching table. Again, we want to do, so this was Deketer, fBurn, I'll go ahead and add this. So this has a modality of functional MRI analysis. Let's start with let's start with fMRI preprocessing. Choose our default parameters for that. We can add the step of, now let's do, so we have Group ICA as our next step. And let's select these amazing parameters that we selected before, that we created ourselves. Let's actually not do Group ICA, let's do dFNC after Group ICA. And we'll do this as our post analysis. All right, so I could then run all of these in sequence. If I go back to the Manage Studies table, I see that all my subjects with FBurn have already been assigned all these steps, so I could just click through in sequence, start, and run them all. To avoid blowing up my demonstration machine, I won't do that, but I could do it if I wanted. So I think that's it for what I can show you today. I appreciate you spending time looking at our tool, and look out for more videos and demos and features added to the site in the future. We look forward to working with you. Thank you very much.